Hello everybody, how you doing? This is Mr. Dowse. In today's lesson, I'm going to cover ratios and proportions. I'm going to make a second video after this that's going to cover more complex proportions. But for now, we're just going to do the building blocks of proportions, and that includes ratios. So what is a ratio? A ratio is a comparison of two quantities, usually as division. This is my definition of a ratio. Comparison of two quantities, and for the sakes of the lesson that I'm going to be doing in geometry, we're going to be dividing a lot here. So a comparison of two quantities, usually as division. It says example, I have an example here of two different quantities, 3 to 7. This is one way of writing down a ratio. There's another way here. I can write down 3:7, or I could use 3/7. This is a fraction, or I kind of look at this as division. All three of these mean the same thing. So if you ever see 3/7, that's the same thing as 3 divided by 7, or the fraction 3/7. Or if you see 3:7, that's the same thing as 3/7. So you need to know that these can be mixed around and they all mean the same thing. But I'm going to use this as a more real-life example. There are a total of 135 junior ROTC students to a total of 1,820 students at school. Write this ratio three different ways. Well, I'm going to write this ratio using these three different ways up here. But what comes first? Is it the 135 or is the 1820? Well, the order that it comes in the sentence is the order that it's going to be in the ratio. And this guy right here kind of tells you that it's going to be a ratio here. And so, I mean, if I were to just look at these lines that are underlined, it's basically this guy right here. So 135 to 1,820. So that's one way of doing it. Let's do it the other way. 135 colon 1,820. Or we can do this as a fraction here, as 135 divided by or over 1,820. Now when it comes to ratios, you generally want to reduce these ratios as much as possible. And I happen to do the math before this. These are both divisible by 5. So if I divide these by 5, I get 27 2, and this is 364. So what does this really mean? This means that out of 364 students in the school, there should be 27 students in junior ROTC. So again, you always want to reduce this as much as possible. I know this is kind of weird here because these numbers are kind of weird, but we're going to do another example down below here that's going to make a little bit more sense. So again, I can also write this down as, or I should write this down as 27 to 364 if you're going to reduce this. And then this could be written down as 27 over 364. Where did I get these numbers? I got these numbers from asking teachers at my school. And this is the assistant principal at my school. Got that number from her. So let's make this a little bit more applicable to a smaller setting. Let's see here. There are a total of 14 girls to 8 boys in class. Write this ratio in three different ways. So 14 to 8. So we have 14 to 8. We have 14 colon 8, or we have 14 over 8. Now this is important here. I put this number bigger on purpose. Sometimes people think that the smaller number automatically needs to go on top or it goes first. That's not always the case. It comes in the order. You write it down as the order as it's given to you. We're talking about girls to boys here, so girls come first, boys come second. Girls are on the top here, boys would be on the bottom here. So again, I can reduce these numbers down if I want to. These are both divisible by 2. And so this would be 7 to 4. This would be 7 colon 4. And this would be 7 over 4. So hopefully you get this idea here. But when I'm a geometry teacher, and it says in geometry we use ratios to compare two dimensions on shapes. So we're going to apply this a little bit more towards my classroom setting. It says find the ratio between the height of a tree and the shadow of the tree. We're comparing the height to the shadow here. So I'm going to put an H for height, an S for shadow. And what is the height of the tree here? Well, we have 15. So that's 15. And the shadow here is 24. So this is how I would compare two dimensions to apply towards geometry. And again, I can reduce both of these down here. They're both divisible by 3. So 15 divided by 3 is 5. 24 divided by 3 is 8. And so this would be the ratio as a fraction, because this question says just write this ratio only as a fraction. And what does that mean? That means for every 5 feet I go up the tree, the shadow should be 8 feet long. And so I could keep doing this. Every 5 feet with 8 feet, every 5 feet we have a total of 8 feet of shadow. And so this would be an example of how you do this in geometry. I've got a shape here. I've got a rectangle. What is the ratio of the length to width on this rectangle? So the length to the width here, so that would be the length to width. And again, I'm only doing this as a fraction because this is how we're going to use this in proportions on the next page here. Well, we're going to compare the length to width here. That's 3 over 7. And so this would be 3 over 7. And I can't reduce these anymore here, so this would be the ratio for this problem. But let's apply this more in a different setting here. I've been doing a whole bunch of ratios here. The whole point of this lesson is to get to proportions. It says right here, a proportion is an equation of two ratios. So notice, this is a ratio here, and this is another ratio here. And it's an equation, so an equation has an equal sign in there. So this is the equation right here, when I have the equal sign going on in here. So I'm going to erase that and back it up a little bit. When it comes to proportions and solving for a variable here, you want to do cross multiplying or cross products, something along those lines. We're going to multiply the numbers diagonally from each other, and I have a 14 times x, and then I'm going to multiply these other numbers that are diagonal from each other, which gives me a 7 times 6. And if I continue doing the math here, 14 times x is 14x, 7 times 6 is 42, and if I divide both of these by 14 to isolate the x, I get x is 3. So in this case here, x is 3. And so I've got a couple more examples here of how we're going to cross multiply and solve for the unknown variable. So I'm going to start it here again. We're going to do the 2 diagonal of the 40. So I'm going to multiply these. Do I have to put the 2 in the 41st? No, I don't. This is just how I solve the problems. Do what you think is more comfortable to you. And then I always put these diagonally second here. So I always put the one on top here, I always place that down here, and the one on the bottom I always place over here. But you can swap these either way. It doesn't matter. You're going to solve and get the same answer. Well, I know here that 2 times 40 is 80, and we have 5x here. And then you always want to isolate at the end. You're always going to divide the last step here on cross multiplying in proportions. And 80 divided by 5 is 16, and that is equal to x. So I know that x here is 16. Let's do one more right here. I'll just keep the same colors here. Cross multiplying here. My goal is to solve for a. This one's a little bit different. That's why I chose this problem. So 20 times 6 is going to equal 5 times 4a. And if I do the math here, 20 times 6 is 120. 5 times 4a gives me 20a. So don't let this trip you up here. A number times a number in a variable is you're just going to multiply it like normal and just carry the variable down. And then you divide by 20 here. Notice I'm dividing at the very end on all these problems. So 6 is equal to a. So this is these are 3 examples on how you would have proportions here and how you'd cross multiply. But I'm going to take this a little bit further here. I'm going to, actually I don't need to erase this. I'm going to show you how to double check your work here to see if you did the problems properly here. So we have x is 16, a is 6 here. So we have x is 16 and a was 6. How can I double check these to make sure I did these properly? Well, if I plug in a 16 where this x is, if I can cross multiply these and they equal each other down at the bottom, then I know I did the problem correctly. Well, 2 times 40 is right here. We have 5 times 16 right here, and if I multiply 2 times 40, that gives me 80. 5 times 16 gives me 80, and since these are equal to each other, 16 has to be the correct answer. And the same thing applies here. This would be a 4 times 6. Well, this is a, so let me see here. I'm going to have a 20 over 5 equals 4 times 6 is 24 over 6. And if I cross multiply these, 20 times 6, and then I have a 5 times 24, Again, 20 times 6 is 120, and 5 times 24 is 120. So since these are equal to each other, I know this is the correct answer here. A has to be 6. Now, these can get more complex, and they will in my next video. So more complex proportion examples are on the proportions 2 video. Hopefully this helps you understand ratios, proportions, and cross multiplying better, and I hope you have a great day.